That breath I just took and you just took and the next one I'm planning on taking is utterly dependent on the ecosystem being healthy. And without it, we're all gone. For a long time, it's all been about trying to make things a bit less bad. Trying to reduce the amount of water we use, the amount of energy that we use. But actually, I think we're past that point now. So now we need to move across to the positive side where our buildings are an active part of the ecosystem. Imagine if we could start to turn buildings into carbon stores rather than being an emitter of carbon. We could have buildings that are generating more energy than they use, capturing every drop of rainwater that falls from the sky and using that instead of flushing it all away and trying to get rid of it. It's using local materials, reclaiming existing buildings. So now it's about, can we make the built environment actually help restore and regenerate the planet? I'm Dave Cheshire. I'm the Sustainability Director in AECOM. AECOM are a multinational building engineering and infrastructure company. So my role is working with developers and people making and designing buildings and trying to make them more sustainable and now more regenerative. That goal is this idea that the built environment becomes part of the ecosystem. We're completely divorced from it at the moment. Our buildings are currently built from materials that come from all over the world. They use huge amounts of resources. They assume that everything is being delivered to them, so the energy and the water is just delivered at a cost, but without any implication, and the waste is just taken away. And we're just free to build whatever we want within planning and regulatory requirements. The impact of that is that it's not just the direct impact of building on that site, but it's also that huge shadow that building is cast in terms of its massive supply chain. Imagine if rather than this very sort of bleak cityscape that it often is, we could bring nature into it and actually say this has a value. So regenerative design is this idea that we're giving back to the planet and our buildings are an active part of the ecosystem. It's about providing what are called ecosystem services back to the planet. Things like purifying air, sequestering carbon into the ground or into our buildings, capturing the energy, capturing the water, and basically providing services that actually keep the ecosystem healthy. There's lots of innovations in regenerative design. One example is one that AECOM worked on, which was the Green School in South Africa. It reclaimed materials. It used lots of very local materials to construct. It's covered in photovoltaics, so it generates its own energy. It stores its own energy. It captures water. It's actually even part of their education process that they understand regenerative design. And then the whole landscaping is just bursting with biodiversity and local flora and fauna. But then all the way through to some really cool stuff around nature-based design. So using sustainable drainage systems, using green roofs, green walls, and then even some ideas around microbial fuel cells. So what they do is they clean up the wastewater, so sewage, out of a building. The microbes actually eat all that, and that's their food basically. And what comes out the other side is clean water, and you can return that to the ecosystem. But as a byproduct, they also generate energy. There's lots of practical examples of regenerative design. Can we co-involve with the rest of the planet, or are we always going to be a self-imposed sideshow, but one that is dominating and actually doing damage to the planet? In Costa Rica, there's an area called Sweet City. There, all of the pollinators, the trees and the plants have citizenship. So they're actually valued at an equal level to the people that live there. which is just such a radical idea. So we're in a linear economy at the moment. So in a linear economy, we dig stuff out of the ground, you use it for a while, and then we chuck it away and it becomes waste. It comes back to haunt us. So the circular economy is trying to move away from that linear model to one where we're closing those loops. This idea that at the moment we just glue everything together and weld everything together in a way that we can't really get those bits of the building back in the future. We can actually deconstruct our buildings rather than smashing them to pieces. Then we leave this brilliant legacy for future generations to do urban mining. We've dug out those resources. Why can't we reuse it? This whole question around how we fund this and how we make this work and stack up it's a systems level problem, because we don't value the ecosystem. We get fresh air for free, and it's got 21% oxygen in it, and yet it's excluded from our economic system completely. So I think we need to find ways to start to value all of those services as part of our economic system. I'm already seeing big clients set themselves targets about improving the biodiversity net gain. We moved from a state where I would walk into a design team and they'll be just like rolling with the eyes and go, oh no, Dave's company is going to cost us loads of money and it's going to be a pain, to actually being, what else can we do? What else can we do to make our building better? After spending nearly 30 years doing this, I think I saw a massive change. I think we're going to have to move even quicker. I think it's very easy to blame the system, but actually, we are the system. We just have to do this. We have to look at ways to protect and restore the ecosystems that are basically our life support system.
Freetown is a magical city. This is a beautiful, busy, cultural, economic, bustling space.
From any vantage point in the city, you're either seeing the Atlantic Ocean and the mountains, or both. But its population, it's exploded. That growth has actually impacted the forest. We lose something like 550,000 trees a year. The notion of Freetown the Treetown was to reverse the deforestation, to afforest, to regreen the city. Technology is really, really at the heart of what we're doing. Growing trees means you've got to stay there with the trees. It means you've got to protect the trees. You've got to look after the trees and monitor their growth. And that's what we do.
House building is threatening our natural ecosystems. So wherever there was forest, there are now houses. The major challenges, flooding is the biggest, landslide susceptibility, water shortages, heat stress, urban heat island effect, massive. Freetown is one of the top 10 most climate impacted cities in the world. It is the most densely populated city in all of West Africa. We have exceeded our biocapacity. We're out of balance, but it doesn't have to be that way.
Planting trees is easy. To ensure that the process is successful, what's most important is the trees don't just get planted, but grow. We have a digital platform which enables the growth of those trees to be tracked to ensure that that sustainability is embedded. And we're really excited because we've planted just shy of 1 million trees.
But we've now set a new target. And so we'll get to at least 5 to 7 million by 2030. The app comes first. It's a very simple piece of technology that is in the hand of a community grower. Sort of that once they plant the tree, boom, they track it. Once they get that digital footprint of the tree and it's verified in our system, then we are able to systematically track the life and the health of the tree.
So let's say if I want to track this particular tree now, you see, I'll ensure that it fills up my camera, then I press the button in between. The process of tracking is also attached to collecting coordinates. At the initial track, a coordinate is attached to it, so it has the location of the planting. They also add a note. The note is the physical tags that we generate, and these tags are actually attached to a tree. Now, once you are done tracking, you have this dashboard. This dashboard tells you how many trees you've tracked, how many trees have been uploaded to the system. After these trees are verified, a token is issued. A token is like a coin that can be transferred from one user to another. If we need to pay growers, they have to demonstrate evidence of survival. So if you are responsible for 2,000 trees, and within a month you only grow something like 1,500, you only be paid for those 1,500. And that was how we are able to ensure that they provide the necessary care and support that is required to grow those trees.
The solution will need sustained investment, which is why we've moved into the development of this framework with carbon offsets.
Then now we are able to determine the carbon footprint, which then enables us to enter into the carbon market.
We create a context that leads to sustainable financing of the reforestation. What we're building here is a green circular economy. The resources that are generated then go back to the growing spaces to ensure that we can fund the reforestation. Our biggest advantage in all of this are our growers. Every tree that has ever been planted and grown is done so by those communities.
The trees are already in so many ways transformative, from the fact that they create employment, skills development for young people, economic product, because 60% of the trees are economic in one way or the other. So either they're fruit trees or they're medicinal trees. One of the things that is important, of course, is that we are planting indigenous trees.
We build a species mix. And so the species mix is designed to ensure that the level of biodiversity is enhanced within the context of a combination of species that are there.
I think the diversity of what we've done has made it interesting. You plant along roadsides, you plant along waterways. We have planting going on in schools, in cemeteries, in hospital compounds. As they grow up, they'll grow up into small little urban forests.
What we're trying to do, it is changing that relationship between people and nature, changing how we value it and understanding the risk dynamics associated with how we live. But if we expect people to change, we have to provide alternatives.
If we're not addressing that and just planting the trees, the rate of loss is going to be greater and the speed is going to be greater than the reforestation. To do that, we need to invest in other things. For example, in alternative cooking fuel. 82% of cooking fuel in Freetown is wood or charcoal based.
We are creating new technologies where we can get briquettes and biogas from waste that is generated from the Freetown waste plant.
It's been fascinating to have other cities come to us and say, we love what you're doing, we'd like to do it. Freetown the Treetown is the precursor to Africa Treetown. And for Freetown to be seen as a blueprint for other cities. The future city that I want to see is one where we bring nature back into the urban lived environment. There's a lot of skepticism about tree planting. So having the technology to confirm that what we're saying is happening has been very important to us. Freetown the Treetown is here to stay. And that makes me feel really, really happy.
Miren, estos son espacios estructurales de ciudad, nuestras quebradas, nuestros ríos, nuestros cerros. Y que es importante es lograr conectarlos a través de estos corredores verdes para conectarlos con el espacio público y así ir llevando toda una trama de un ecosistema estratégico para la ciudad.
Medellín has suffered rising temperatures due to increased pollution and rapid urban development. By introducing a network of green corridors, average city temperatures have been reduced by 2 Celsius, while also improving air quality and urban biodiversity. Temperatures are expected to fall by a further 4 to 5 Celsius over the next 30 years.
En 1991 llegó a ser la ciudad más violenta del mundo. En el 2016 empezamos a reflexionar sobre cuál era realmente el futuro de Medellín si no tenía sostenibilidad ambiental. Corredores verdes es adaptarnos a las necesidades ambientales de la ciudad, sembrar más árboles, sembrar más plantas, que vuelva la vida a nuestra ciudad. Cuando tomamos la decisión de sembrar los 30 corredores verdes, nos basamos en aquellas zonas donde más necesitan el aporte ambiental. Hoy con esa intervención hemos logrado reducir temperatura en más de 2 grados centígrados y ya la ciudadanía lo siente.
Tenemos 53 obras en proceso y ello hará que el centro tenga su transformación, no tanto física, sino también a nivel social. Hacemos que los ciudadanos se comprometan con una cultura ciudadana del cuidado de los individuos arbóreos, igualmente del buen uso de la recolección de las basuras, la convivencia ciudadana y que el centro es un territorio de diversidad cultural, de diversidad sexual, de diversidad política, de diversidad social. Medellín será una muestra de ciudad para el mundo.
Miren, muchos sitios de la ciudad se habían convertido en basureros, al lado de las quebradas. Se habían convertido en sitios de consumo de droga porque eran sitios abandonados, aislados. Y lo que hemos hecho es transformarlos en jardines. Volvieron los niños, volvieron las familias, la comunidad los cuida, les da cariño y la gente sabe que es de ellos. Porque lo que hemos hecho es contratar muchos más jardineros y eso nos ha permitido capacitar a mucha gente que no tenía trabajo, no que les gusta lo que hacen y la gente los va viendo por toda la ciudad.
A veces hasta nos dicen son el pulmón del planeta, imagínense. Entonces, por ese lado, gracias a Dios, la gente nos aprecia mucho.
Para mí, lo importante no solo es el momento de definir un proyecto y sembrarlo o construirlo. Lo más importante es lo que viene después. Sin apropiación de parte de la ciudadanía, es imposible lograr sostenibilidad. Cuando uno ve todo el ecosistema, cuando uno ve las mariposas monarcas ya de nuevo, cuando uno ve las abejas, cuando tú ves los pájaros de nuevo en estos corredores donde ya no estaban, ahí es donde uno entiende que regresó la vida a donde vamos llegando con los 30 corredores verdes de Medellín. Todos tenemos que tomar acciones locales para que impacten en lo global. Está funcionando y ojalá se replique en muchas ciudades de América Latina y del mundo entero.
When you walk down a street and there's no trees on it, it's not only a lot hotter often, but it's also a much more intimidating and horrible place. But when that street has trees and life and birds and noises in it, you know that that is a much more healthy ecosystem to be existing in. Finding the systems through which we can all engage in nature restoration is going to be absolutely essential for us to move to the next step, which is engaging the entire public in the global restoration movement. I truly believe that urban restoration efforts are absolutely critical to this movement.
Wild West End is a Crown Estate-led initiative which was established back in 2015, where A number of the core West End landowners came together to work on how we improve the quality and quantum of green space within the West End. My name is Yvonne Aki-Sawyer and I'm the Environmental Sustainability Director at the Crown Estate. Green spaces don't just provide a biodiverse impact, we recognise that there are wider ecosystem services that biodiversity brings. At Wild West End, we're committed to making sure that any green space we provide meets at least one of two other values. These may include microclimate benefits, air quality benefits, health and well-being, water retention. There are a huge number of benefits, but it's just trying to, again, find what is right for that location.
It's good for people to be around greenery. In terms of an urban city, you quite often come across just lots of concrete, lots of walls, no living walls, nothing that was particularly attractive. There wasn't a great deal in terms of wildlife happening across the West End of London. By putting more plants and more things for animals and invertebrates, birds to come into this area, we have established a haven really for lots of different wildlife in the city. Bees are really important. We have up to 250 species of bees in the UK. They are all pollinators of different types, and there is an opportunity with honeybees to actually farm them. They are wild, they are livestock. There's approximately 400,000 hives in the UK, and in Regent Street we've made the decision that we will keep bees on the street.
My role is to look after the bees, making sure they've got everything they need to survive and look after their well-being. My name is Del McCann and I'm the beekeeper on the Crown Estate. We were quite worried at the start when we installed them about the level of pollution. Will our bees actually survive? We've found over time that bees are happily surviving up here.
Responsible beekeeping is really important because in certain parts of London there are too many bees. We need to know where bees are located because if there are too many bees in an area, that means there isn't enough habitat, there isn't enough forage for the bees to thrive.
I mean, they pollinate all the plants. We can't put bread on our table unless bees are out there being active.
We're talking about really having bees in an area where they can thrive and they can bring other wildlife into the area as well. That's the really important thing.
We try to encourage people to plant more flowers, more vegetables, make more wild spaces in the gardens, try and make the environment more friendly for the bees. We help them, they help us. It's a two-way cycle.
Sustainability has always been a really important part of how we at the Crown Estate operate. It aligns very much with our purpose, and our aim is to make sure that we're always creating financial value but also environmental and social value for both now and in the future.
Since the 1970s, we've lost 41% of our species in the UK. We're now seeing many more sparrows, greenfinch. We're seeing a lot more pied wagtails and black redstarts. Those latter two have been in very low numbers, so it's great to see them coming back into the area. Maybe that just gives you a little bit of a flavour of the kind of things that are happening. They don't happen overnight.
We've been focusing on prioritising local and native bat species. It's also about creating not just new insects, etc. to come in, but also how do we create the right habitat.
We do encourage bats to come to the estate, and we do know that there's a very large population of them in St James, and we want them to be there. They're all part of what makes up our city.
Collectively, we can make the entire West End a much nicer destination for people to come to.
I can't think of any customer on Regent Street that is not engaged with an aspect of sustainability. And I know that's happening in a lot of towns and cities now, that people are beginning to think that in order to make this work, we can't do it in isolation. We have to do it as a community.
I do believe that what we've done in central London can be replicated elsewhere. If we're able to do it in a pretty constrained site like London, then we should be able to do this anywhere.
Many people don't know this, but heating and cooling of buildings and transport refrigeration accounts for 25% of the world's CO2 emissions. It's very important that we start to look at how the energy is used in buildings. It's an industry which has been very traditional in the past, and it's ripe for innovation. Buildings could have the potential to become energy sources. There is no decarbonizing our future without decarbonizing buildings. Traditionally, buildings weren't cooled. If we go back 200-300 years, cooling is quite a new thing, but heating has always been done in buildings, and heating has always been achieved through burning fossil fuels, initially burning wood, later burning coal, and eventually burning natural gas in gas boilers. Today, most buildings have a cooling plant and a heating plant, and those plants are not connected. And what is really absurd is that a lot of times buildings require heating and cooling simultaneously. My name is Jose Loggia, and as a mechanical engineer I like to create things, I like to innovate. I studied engineering in Sydney in Australia, and mechanical engineering. I graduated in 1994 and I basically joined Trane the week after. Trane Technologies is a heating and cooling company and a transport refrigeration company, and we consider ourselves as climate innovators. It's a sector which can really contribute to the reduction of CO2 emissions. We see a future where we have renewable energy production, heating and cooling of buildings, and some sort of energy storage, whether it be electrical storage or thermal storage, all acting in unison to create even more efficient buildings. A net zero building generates enough energy to run its own facilities without taking energy from the grid. They repurpose energy, so they recover energy, and they drive a lot of energy efficiency. If net zero buildings were the norm, we would have less pollution because there would be less energy being used, less fossil fuels being burnt. When we talk about heating and cooling of buildings, we need to understand that there is free heat all around us. We need to be able to move heat, and this is the concept of the heat pump. Combining heating and cooling can not only happen at the building level, but it can happen at the city level. A great project we worked on was with the city of Aalsmeer, where they had a data center, a school, and a gymnasium. So the data center was being cooled and rejecting heat, and the school and the gymnasium needed heat to heat their facilities. So what the city did, it incorporated a Trane heat recovery system to recover this heat and use that to heat the gymnasium and the school. And by doing so, they save 400 metric tons of CO2 emissions, the equivalent of 48 homes on a yearly basis. Some of the obstacles to creating net zero buildings are not technological, they're really cultural and traditions. And we need, as an industry, to change those traditions to start to look at the services in a building in a more combined way. For example, one obstacle that always comes up is cost, that these solutions are more expensive than traditional solutions. However, implementing these new technologies, because of the energy efficiency and the reduction in CO2 emissions, they have very short payback, sometimes within the 2 to 3 year period. Another perception is that these systems are very complex to implement and that they can only be applied in new construction. However, this is not true. 75% of our business is a replacement business. We replace chillers, meaning we replace machines that produce cold water. When you're replacing cooling-only machines with machines that make heating and cooling, the incremental cost is not so much more. Financing is sometimes seen as a barrier to achieving net zero buildings. However, financing is always there. We just need to finance the future, not the old systems. When all of these barriers are broken at the building level and at the city level, buildings will no longer be energy sinks, they will be energy sources. I believe we can get to net positive buildings, and the reason I give for that is that if we think about today in Europe, there are some countries producing more energy that is required. So the goal then is to connect that excess energy to buildings, and then buildings can become net positive. These breaking of silos, whether they're energy productions, energy storage, heating, cooling style, as we combine all those silos into one net zero building, there is an incredible amount of innovation that can happen and an incredible amount of creativity. So it will happen. It's just a question of time.
Buildings are full of potential to make people happier and healthier. They're full of potential to help the planet as we cut carbon, cut energy and water waste. Net positive buildings would drive so many really important outcomes. It's an invitation for us to unlock our creativity. Let's enable the building to become like a neural network where all of the operating systems talk to each other, keeping that air healthy and clean inside that building, making it so that you're always comfortable in that building. It's a vibrant, healthy, thriving place, organic, agile, flexible. And guess what? You're going to be smarter and more productive too. This is the future we can realize. So let's look at the big picture. Buildings represent almost 40% of global greenhouse gas emissions. 75% of that is in operating the building, 25% is in building it to begin with. Buildings right now are largely just a burden on the balance sheet. They're a challenge for the planet and not good for profitability either. You gotta ask yourself, can't we do better? I'm Katie McGinty. I'm Chief Sustainability, Government and External Relations Officer at Johnson Controls. We're at an inflection point where the old way of both making and operating and running buildings is beginning to give way to the much better model. We have technology now to make the construction much greener. We can recycle steel and cut the carbon in that steel by almost 80%. When we redevelop properties, we're recycling, reusing materials. On the operating side, we'll be efficient. Let's totally electrify building. We can deploy heat pumps, for example. What do? They can heat and cool simultaneously. When it cools a room, it pulls the heat out, but instead of throwing that heat away, it puts it to work in creating hot water. Putting data and digital systems to work is the real game changer for buildings. We have meters and sensors that can very precisely tell us, hey, the refrigerant is low in the HVAC. Why don't you fix and repair that? The building can become like a battery, able to actually speak to the grid and sell energy back to the grid so that we can supercharge our ability to electrify transportation and the economy and pull the carbon out. We can paint a picture that is very compelling. Yes, it's about doing the right thing and tackling climate change. It's about helping your bottom line by cutting your energy costs, but it's about so much more. It's about a school district in Colorado that's saving $1 million a year as they cut their carbon 25%, and then investing that back so the kids have the best education. It's about the hospital that sliced its energy bill 50%, but employed digital sensors that also detect and destroy germs in that hospital so the patients get well quicker. Government and policymakers have a critical role to play. Right now, we have policies and incentives in place that are providing grants and upfront resources to enable building decarbonization projects to get going. We also see incredible partnerships between the public and the private sector where we are pooling our finances, our technology, and our expertise, and then guaranteeing very significant carbon and energy savings. A lot of times we have an idea that if it's good for the environment, it must be bad for the economy. But I think we are unlearning that. We're at a very exciting point of change with buildings. I'm hopeful because we have the technology today to solve climate change, and when we get about tackling that problem as it relates to buildings, we unleash all kinds of potential because we're bolstering the bottom line, and it's going to enable us to demonstrate that what is good for the planet is pretty good for our profitability as well.
Nowadays, we can transform wood, which remember is the most versatile material on Earth, into a totally new range of biosolutions that can replace fossil materials in sectors like construction, textiles, chemicals, transport, or packaging. We can now produce wood engineering products that can replace steel and concrete, not only reducing the carbon emissions compared to those non-renewable materials, but transforming our cities in carbon storage infrastructures. For every cubic meter of wood that we use in a building, we are storing 2 tons of CO2.
Our ambition was for this building to be one of the most sustainable buildings in the world. We soon saw that timber, being the only renewable building material there is today, is a good way of achieving this. So our proposal was based on doing the entire building in timber. My name is Robert Schmitz, and I'm one of the lead architects for Sara Culture Center.
The wood is sourced from the local forests, about a radius of 100 kilometers around Skellefteå. The sawmill is also located very close to the city, so everything is from the region.
My name is Oscar Norelius, and I'm one of the lead architects for Sara Culture Center. Timber and wood as a construction material is something we've been working with for a very long time in Sweden. The reason for that is that we have huge forests. The resource is almost endless here. And this means that we've built smaller houses historically, but we've also developed new techniques of building larger and more complex buildings with engineered wood. It's a very daring project. It took a very daring client to realize a project like this, but we felt that there was such an interest and engagement here that this was the place to do this.
We have always had this strong vision. The vision is that we are going to take lead in the green transition. Skellefteå is going to be a sustainable place for a better daily life. My name is Kristina Sundin Jonsson, and I'm Skellefteå's Chief Executive of the municipality.
The Sara Culture Center is powered by 100% renewable energy. The electricity and cooling comes from the river, and heating comes from district heating from biomaterials. We developed new ways of channelling timber and utilize timber into bigger slabs. The columns are glue-laminated timber, and the ceilings is from cross-laminated timber, which has been mounted in elements and prefabricated in a factory just outside Skellefteå, and then assembled on site. We also have added an extra centimeter of each column so that it can withstand fire for a longer time. Timber binds carbon dioxide, and it balances the embodied carbon within the construction and all the materials being used in this project.
This building is climate positive thanks to the timber structure.
We've designed the building to be a landmark, a showcase for sustainable design, sustainable construction, something that's becoming an image of the city of Skellefteå.
I think we needed a center in the city, a new meeting place, and we always knew that culture and leisure is truly important for make people really love to live here.
This is the most central plot in the entire city. Before, this was used as a bus station and a parking space. And from the original town planning back 100 years ago, this was meant to be a prominent building. I think it becomes a new landmark for the city, especially in this setting, overlooking the entire city of Skellefteå.
Sara Culture Center houses 4 cultural operations: the Västerbotten County Theatre, the Municipal Library, the Art Gallery, and the Museum Anna Nolander, combined with the Wood Hotel, with the conference center, 3 restaurants, and a spa.
For us, it was very important for this building to be a culture center, not just several units. We wanted the operations within to coexist so that they can strengthen each other by collaboration.
This house, it invites people who come to visit to really want to be tactile and touch the walls and smell that particular smell that is wood. My name is Francesca Quarte and I'm the CEO of the Västerbotten Theatre. I think that in connection with our old tradition of being a country of large forests and of course our indigenous people, the Sami people, who have long lived in collaboration with nature. Culture is the bridge between the old and the new, and I would say that we want to connect and reconnect with that past.
This building is about empowering the community and letting the people have a new public place where they can meet and also to feel at home in.
All the inhabitants, all the businesses that are around here are really dedicated to contribute to this vision.
It has to do with sustainability when it comes to the beauty of our city, the sustainability in how it will be possible for different sectors of society to work together. And it's made visible with this house.
You can really see the change, the transition in Skellefteå for the last couple of years. You can already see that this house is vibrant with young people, elderly people, with people from all over the world. It's really a picture of the future of Skellefteå.
We're in the start of a green revolution with this building, leading the way for a better sustainable future in construction.
Sara Kulturhus is the perfect symbol for sustainability in all aspects, socially, economically, and environmentally.
There are many things happening here attracting people, and this becomes the image of all of those developments.
I think other cities can learn that we have loved to cooperate with others. That's the success of Skellefteå, because we are not alone on this journey.
To build such a tall building in wood, all of it, that has sent a signal throughout the world that new things can be done in ways that perhaps nobody thought about before. Something exciting is happening here. The entire world is seeing that. And that sense of pride, it cannot be underestimated what it does to a person to know I come from a city that I would say really is the future.
By 2050, there'll be 3 billion new people on this planet. In order to house them, we're going to be building the equivalent of a city for 1 million people every 5 days.
Already, Portland cement production is responsible for 8% of all CO2 emissions. We need to shift away from the way that things have been done in the construction industry for the past 200 years. If you look hard into nature, you can see many challenges have been solved. It's really about us utilizing those lessons and learnings into biotechnology for the construction industry and how we make the materials of our future. We're in a biotech revolution.
Concrete is the single most consumed substance on Earth following water. As population grows, we need more places to live. We need dams and highways and bridges. The downside of concrete is that it has a fundamental chemical reaction that requires the release of CO2 in the environment. So the building block of Portland cement is limestone, is calcium carbonate. We dig that out of the Earth's crust, we burn it at 1450 degrees Celsius, we release the carbon dioxide, and we're left with calcium oxide, the active material that enables concrete to exist. How do you create a carbon neutral version of cement? To solve that problem, we have to go back to the fundamental chemistry.
So the idea to grow cement came from reading about how nature is able to grow this strong and durable cement all around us, including marine environments. I asked the question, well, what if you could grow it?
There's an estimated 1 trillion species of bacteria on planet Earth. They are capable of producing materials that have different structures, different kinds of performance features. They take that same limestone, that same fundamental material we use to produce Portland cement, but they decompose it and reform it into new forms of limestone that are cementitious, that are like concrete, that create shells and coral reefs and strong biological structures.
So So Biomason is a technology company. We use microorganisms that are responsible for creating calcium carbonate cements and aggregates. We're actually using the blueprints from nature to make an alternative to Portland cement.
So Biomason is the only company in the world currently producing commercial products in the form of concrete using bacteria to grow the cement. So we're unique in the sense that we are using biology itself and the way that the planet makes concrete and has long before humankind.
So the starting point for our biocement is our bacteria. It's the same thing as making beer, but we're making cement. We grow it in our lab and stabilize it. We then add it to our aggregate, which we take as a waste product from mining facilities. We then put it together and mix it up, get our bacteria alive and happy, and then use our press here to stamp out product. We then put it into our hydroponic system where we seed it with our calcium and the nutrients to help the bacteria live. It takes about 50 to 72 hours to process from a sandcastle into a hardened brick at ambient temperatures. And so as soon as our units are dry, that bacteria is no longer active. The process of making biocement has a significantly reduced CO2 output because we are able to harness the power of bacteria, generating a lot less CO2 through that process. Currently, we are producing a thin tile that can be used for indoor or outdoor application, but we're excited about future versions of our technology. 80 to 85% of the market is dominated by the ready-mix industry. In order to get to our goal of reducing CO2 emissions by 25%, we need to get into ready-mix. What excites me about the future of the construction industry is imagining what our world's going to look like in 100 years from now. We knew from the beginning that to make the biggest impact that we could not just be one plant, that we had to be able to go into existing manufacturing, be easy to use, and utilize the same equipment that's used in standard production of concrete materials. So we're starting with tiles, but that's just the beginning. Being able to grow your concrete, being able to leverage this wonderful biological perspective will start to become normalized. We're at an inflection point for our planet.
The potential for creating different construction materials using biological systems is potentially endless. I believe the applications for biotechnology are correlative to the biodiversity of the world around us. Humans have looked at about 1/1000% of bacteria, and we're only really starting to learn how to harness that for engineered applications in our world.
The organisms that we are surrounded by are trying to do exactly what we're trying to do. They're trying to build their homes, trying to make materials. And when you realize that, the false separation between us and the rest of the natural world starts to dissolve away.
When you think about the big sustainability crisis in the world, one of the things that people are always talking about is the plastic problem.
Only 9% of plastic ever produced has been recycled, with the majority ending up in landfill or escaping into the environment. Continuus Materials rescues waste destined for landfill to create building products like their Everboard, a highly durable roof covering made from waste plastics and paper. Every 1,000 square feet of Everboard installed prevents 800 pounds of plastics and 1,200 pounds of paper from being landfilled, and it is fully recyclable.
I'm Bridget Luther. I'm the Sustainability Director for Continuus Materials. We've merged the building industry with the waste industry and sustainability to make Continuus Materials a leader in the roof cover board market. We have really embedded circularity into our whole business model. For every square foot, we are recycling 2 pounds of previously landfilled materials. And we're doing that at a scale that will really make a difference.
The way the Everboard starts is that material gets shredded. It comes down this system of conveyors. One of the first steps is we move over to our magnets where we take metals out. We then go through a couple different steps of separation and drying it, and ultimately into our board plant at the other end of the facility right there. My name is Rick Cochran. I'm the Senior Vice President of Business Development for Continuus Materials. Single-use plastics are inexpensive, but can have a high environmental cost at the end of life if not handled effectively. We're able to mine paper and plastic in the right combination and then create a board that has everything a customer's requirements are for that roof. In the building products industry, if you can't get to large volume scale, your products are never going to gain deep acceptance in the market. We're currently producing about 8 million square feet a year of product. Our next facility will produce 150 million square feet of product. We have a very aggressive mission statement. We talk about getting 500,000 tons a year diverted from landfill and reclaiming that paper and plastic. That is meaningful and challenging, but it's also what we can do.
It's estimated that if we don't change our waste management practices by 2050, there will be around 12 billion tons of plastic litter in landfills and the environment. We don't have enough places for all the trash that we're creating. There is a true problem with plastic waste in the world, not just in the United States, but all over. Sustainability is also about looking to nature and what can we learn from nature. One thing we know is everything gets turned into something else. There is no waste. And that's the world we want to create. We can all be really inspired towards circularity. Innovation and sustainability needs examples. Taking a low-value material and turning it into something that's high-performing is going to be an example for the rest of the world. In the environmental community, we're always worried that change is not happening fast enough. At Continuus, we're doing our part to make change happen as fast as we can.
We need to continue the work being done to rethink waste. And what we've got to make sure is that this doesn't slow down.
We can make things that have a positive force for the planet. If we just start designing in the right way, there'll be enough to go around for everybody.
Fungi are fascinating. They're weird and funky. They are the ultimate alchemist of this planet, and they're able to do so many great things for us. We can learn from nature to solve some of the world's biggest problems. There is no waste in nature. There's always something else that takes advantage of the byproducts.
We're trying to emulate that here at Mycocycle with mushrooms at our core. They're cleaners and they're builders.
We're able to unlock the power of fungi.
So Mycocycle is a process that trains and develops fungi to be able to treat industrial waste streams, particularly construction waste. We're able to not only detoxify waste, but to transform it into new materials in 2 weeks or less and in just 3 steps. My name is Joanne Rodriguez, and I am the founder and CEO of Mycocycle. The waste generated in the construction industry takes up space in landfills, and it can leach toxins into the air, water, and soil. 40% of all greenhouse gas emissions are generated from global construction activities.
The current methods to handle construction waste are not sufficient. We have a huge amount of this waste left over that is not being converted or not being reused. Through the use of our technology, we will speed up the conversion of these waste streams into reusable materials. My name is Daniel Reyes. I'm the technical co-founder of Mycocycle and the Vice President of Research and Innovation. Microremediation is the use of fungi to neutralize and even degrade toxic constituents in nature. So every day we're on the hunt, going out into nature.
looking at places like landfills, oil spills, urban centers, and finding fungi that have developed tolerance or an ability to break down and survive those conditions. So for the most part, we observe fungi through their reproductive organs, right? The mushrooms, the fruit bodies. Mycelium is underground, they're unseen. So mycelium is different from that fruit body in that the mycelium is actually the vegetative part of the fungus. It's made up of hyphae that are interwoven within one another, expanding their overall structure. In nature, mycelium are great at decomposing organic matter that are very hard to break down. And we can translate those properties into decomposing construction waste. Slowly, carefully, we teach the mycelium to eat trash by exposing little bits at a time until the mycelium has developed an affinity for these materials. So we mix our base substrate with our construction waste. The mycelium first attacks our base substrate. It kind of gives it a little bit of an energy boost. It starts to secrete this cocktail of enzymes and other metabolites. At the same time, the mycelium will make a jump from that base substrate to the construction waste, and slowly they start to break down this construction waste.
It goes into incubation for a period of 2 weeks. And then we harvest it, we stop the growth and process it to become a fiber or fill to meet the needs of manufacturers in the raw material market. The mycelium itself has a physical property that lends itself to fire resistance, water resistance, light weighting, and thermal insulation. It's very, very strong and can penetrate even some of the smallest structures, like in textiles. Our Mycofill G is a composite raw material from gypsum board and mycelium. It's a redless chemical-free material, and we can make mycofiber, which is a shredded version, and we can make what's called a mycofoam. Mycofiber and mycofill can go into everything that you see around you, including concrete, walls, floors, ceilings, furniture. For every ton of waste that we treat, we're able to reduce CO2 emissions by almost 3 metric tons.
The potential of waste, I think, is actually a very funny phrase. Waste is defined as pretty much it has no use, but we see it as a valuable feedstock. So in order to harness the value of waste, it's going to take reframing that term waste and the way we think about end of life. All of these materials that are going to landfill today, whether that's cellulose fibers or fiberglass or even rubber, have really interesting innate mechanical properties and physical attributes that should be given a second opportunity and a third opportunity and a fourth opportunity that can be used towards creating the materials of the future. Mycocycle is bringing that technology to unlock this.
We're looking at scale solutions in a couple of different ways. One is through our mobile bioprocessing unit that allows us to decentralize waste management. We can roll up on site, plug it in, and be ready to go. And then big picture, we're going to have large-scale facilities that could process materials into new raw bio-based applications. Globally, Mycocycle hopes to treat 1.5 million tons of waste a year within the next 5 years. It sounds kind of crazy, but when we think about all the waste that exists out in the world and all of the opportunities to create value in the new markets, we know that it's absolutely plausible. So we'll be able to take the waste at some point in time without getting paid for it. We will need the waste to create our raw materials, and we can responsibly get into these markets that present revenue opportunities and closed-loop ecosystems.
The future of construction is entirely circular. The way that we are using resources right now is a very limited version of what is possible.
The opportunities and applications of mycelium are incredibly far-reaching. I think we are really just scratching the surface.
So we have the opportunity to help nature be a value player to our economy. The world I imagine with more mycelium solutions is just cleaner and more efficient. In fact, I think mycelium is at the core of the circular bioeconomy and fights climate change with nature.
By 2050, there'll be 3 billion new people on this planet. In order to house them, we're going to be building the equivalent of a city for 1 million people every 5 days.
One of the biggest problems with carbon emissions in the world are urban environments and the building products that we make. The building industry is almost the bullseye of hitting carbon for the world. The new buildings, of the roads, the airports, the bridges, the sidewalks. We want to lessen the ecological footprint of these new cities we're making.
So the question is, how can you design so that our buildings, the places where we live, work, and play, start to have the same ecological performance as the wildland next door?
Buildings can be a wonderful sink for all that CO2.
Concrete is about 8% of global emissions. Blue Planet is capturing that CO2 at low energy and utilizing it as an ingredient in a product that we need.
The closest thing to what we do is the formation of a lobster shell. So you know how lobsters shed their skeleton to grow and then remineralize a very thick skeleton? Well, they do that in a few hours. It's the exact same mineral that we use, that we make here. At Blue Planet, we capture the CO2 and we turn it into limestone. Limestone is the skeletons of marine organisms, and we're making synthetic limestone. So by capturing CO2, turning it into limestone or calcium carbonate, we have the capability of permanently sequestering most of the carbon in the atmosphere.
Calcium carbonate is what you put in cement and in concrete, and it's what you put in aggregate that they make roads with, gravels and things like that. And most concrete in its manufacture, it emits carbon dioxide. So this actually sequesters it.
Our inputs are carbon dioxide, and there are a lot of different sources of carbon dioxide. Power plants alone put out about 15 billion tons of carbon a year. But industrial plants like cement plants and steel mills are also putting out quite a bit of CO2.
See that pipe coming out of the ground? That's the flue gas pipe bringing flue gas from the power plant where the CO2 would have gone into the atmosphere. So we're capturing the CO2 and forms a sort of a milky material that's got calcium in it, and it's got ammonia. Then it goes through a filtration process, and it comes out the back as rock. And we're using these rock as aggregate in the concrete. But these are 44% carbon dioxide that's permanently crystallized.
It's very exciting. When Blue Planet captures that CO2, put it in concrete, it is permanently sequestered.
The process works in the local circular economy. We can take old concrete, instead of using it as landfill, and repurpose it. And we're dissolving the calcium oxide out of it. And we take that calcium-bearing solution to go make the carbon-captured product. And then we take the remaining material, which is the original sand and gravel, back to the market to be reused for new buildings. So instead of mining new rock up in British Columbia and shipping it down here, by recycling the old concrete that would have been landfilled, we're saving thousands of miles of transportation and hundreds of acres of open pit mining of rock.
aggregate is the second most used substance on Earth. So it's a way to have an urban quarry of recycled, sequestered CO2 in a circular fashion. Blue Planet will be all over the world with factories and manufacturing plants. Ideally, we'll replicate this kind of water, port, near CO2 sources, near the built environment with large demand for our product around the world. So we're going after the concrete industry. But in a way, we can play with the steel industry as well, because we can capture their CO2, and we can also use their slag as a geomass and put them all together. We can make all buildings better. We can make them net zero into the regenerative. We can capture the water. We can also use new materials and new technologies. We have to change the entire design, construction, and operation practice.
Sometimes we can make a whole building carbon negative, even though it's got heating and cooling. And most electric power in the world is used for air conditioning. And now we're looking at really reflective materials, and you see it in pearl. It's called luster. And it turns out that reflects a lot of light. So if you can make a roof out of these highly reflective materials, you can dramatically lower the amount of air conditioning. So if you don't heat it up as much, you don't have to cool it down as much. And now we're looking at reflective pavements as well. And so it's a whole new movement. It's called the Cool Cities movement.
We have to learn to do what all other organisms have learned to do. You know, look around and use local materials, and then reuse and recycle those materials over and over again.
We can create a better, sustainable built environment and make sure the impact is regenerative.
Waste is what happens when fantasy and innovation stops. Waste is a huge liability if it's not treated right, when it's in the rivers or in the oceans. But it is a resource if you apply adequate waste management options. Then you can turn it into a resource, energy, or new material.
Almost 70% of the world's population is expected to be living in cities by 2050. Dealing sustainably with the increased amount of waste that this will generate is one of the major challenges facing us today. In the centre of Copenhagen, the striking Copenhill building blends recreational space with a clean waste-to-energy plant, a landmark that embodies the city's highly ambitious 2025 net zero emissions target.
My name is Jacob Simonsen, and I'm the CEO of ARC, Amager Ressourcecenter. We have very ambitious owners. They have a very high environmental standard, have very high ambitions regarding environment and climate. When we were to build a new waste-to-energy facility, they wanted us to build the best possible. Normally, when you look at a city map, you see the green areas. Those are the parks. Then you have the pink areas. Those are residential areas. In the future, when you have a city map of Copenhagen, the place where we are now will be a green area. It's a park area. This is a place where people can come and relax and enjoy.
We actually have two lines here. What you can see is that one on the left and one on the right as kind of access down through the factory. And it starts in the very bottom and the waste kind of moves up towards this area. And what you actually see here is the filters. The filters to catch the dust. You have the scrubbers to catch some of the environmental hazardous materials. And all the way from back to here is actually cleaning technology. And then you have the stack that will come out through the factory right there.
We wanted to embrace our local community, and that is actually what we set out in the tender for the architectural competition. One of the bids were from Bjarke, who drew this ski slope. It was absolutely ingenious to look at it in this way. It is kind of a fantastic idea, and it is a ridiculous idea.
My name is Jakob Lange. I'm a partner at Bjarke Ingels Group.
We are approximately 600 people, designers and thinkers, trying to sort of imagine the world that we want to live in. Architecture has a crucial part to play in sustainable urbanization. The term architectural alchemy is this idea of taking two very different ingredients. In this case, it's a waste-to-energy power plant and a ski slope or a public park. And we merge this together. And without those two components, this project could never have become. So the idea is that by mixing these very unlike ingredients, you get, if not gold, Copenhagen.
There was a big political debate when the plant was in the planning phase and before the final decision. Is it too big? Is the capacity too much? Indeed, that is still in Denmark a debate. But having said that, to build the world's best waste-to-energy plant with the highest level of environmental performance and also looking into having full climate protection is actually a very good idea.
Building sustainable is a little bit more expensive. The whole idea is, of course, that you get it all back over time. So buildings will be more energy efficient, therefore you need less money that pays for your heating of your building. Now governments are realizing that it's important to regulate the building industry. Copenhagen is an extremely important puzzle in the whole sustainable crisis that we are facing in the world. Copenhagen becomes an image of how to tackle the sustainable challenge with waste.
We deliver clean energy to about 150,000 households' need of energy every year. If you did not have waste-to-energy in Denmark, then either we would have to export our waste to other countries and there would not be capacity enough for it to be burnt, or we'd have to put it on landfill. And then it would sit on landfill and it would create methane, which is a climate gas that is about 21 to 25 times as strong as CO2. We are a very flat country. So either we move forward on this agenda or we all stand in water onto our knees. There's a sense of urgency that we have to move on, and we are moving on. If it's fast enough, we always want to go faster.
We must reinvent the way that we think about urban architecture. Sustainable design benefits both the community and the planet.
Instead of just talking about it, let's make it happen.
Plastic in a universe of materials is an incredibly efficient and robust material. A lot of our lives are enabled because of the idea of plastic. The issue is not plastic as a material or any other material. I think it's us dishonoring material by using it for an incredibly short period of time and then not having a second life for it.
We're totally addicted to plastic as a global economy. Plastic is all around us in so many different forms. When there's so many forms of it, it's quite hard to sort it and deal with it and recycle it properly.
The human species is about 100 times more wasteful than it was just 70 years ago. So we're producing a lot. Then, if you think about how the solutions to garbage work, what tends to be recycled is not what can be recycled. This is a huge misconception. Instead, what is recycled is what can be recycled profitably by garbage companies. My name is Tom Zaki, and I'm the founder and CEO of TerraCycle and Loop. TerraCycle is a global waste management company. We're headquartered here in New Jersey, but operate nationally in 22 countries. Our mission is not just to manage waste, but to eliminate the idea of waste. And we do that by recycling hard-to-recycle things, then integrating recycled waste back into consumer products, finally through Loop elevating supply chains from being disposable to fully reusable.
Tom had the real foresight to take a look at an area that no one was actually doing, and that's the recycling of number 7 plastic. Prior to TerraCycle, all multi-layer constructed materials were put in the landfill. Many people who thought you could not recycle number 7 plastics because they wouldn't be any use. We were successful in showing the rest of the world what could be done with some of the materials that they considered non-recyclable.
TerraCycle focuses on the things you can't put in your recycling bin. I think technically it's in the thousands of different waste streams, so everything from dirty diapers to cigarette butts, from toothbrushes to cosmetic packaging, and it goes on and on and on.
So, for example, we take juice pouches and turn them into something like lunch boxes. Coated paper into fire logs, or corks into cork boards. Here's another one where we take chip bags. We turn it into this type of plastic and turn it into dog bowls or toilet seats. You can see everything can be recycled in the end.
The fundamental issue of recycling is one of economics. The entire essence of our business model is turned on by finding stakeholders, could be manufacturers, could be retailers, that are willing to fund whatever it really costs to collect and recycle that waste stream versus whatever we can sell the material for. And once we have that economic unlock, then we can go out and collect and recycle just about anything.
All of these chairs and tables were made from juice pouch material. We shredded the materials, melted it, made it into granules, and then the granules were actually formed into lumber to make these chairs and tables.
We're dependent on finding stakeholders who really want to invest and do the right thing. So you can go out there and recycle things you could never recycle before, absolutely for free.
Everyone has their role to play. I think there's great potential for consumers to have an impact. I think as individuals, we don't always know how to have that impact. The level of environmental consciousness amongst young people now is really high, but it's not just a consciousness. We're actually on the streets being vocal about this, which is an exciting change, actually.
From a consumer experience, the way you would experience TerraCycle is you could go to TerraCycle.com, our website, and type in any waste stream you want to recycle. And then if there is a program that's been funded by a stakeholder, like a brand or a retailer, you're going to see a free program appear to you. And if there isn't someone funding, then you'll see paid alternatives. Now, let's say you enter into a free program, and that entire experience is free to the consumer. Now, someone's paying the bill, and the people who are paying are, in these examples, manufacturers and retailers. The price of your product isn't going to increase because of those costs. What they're doing is, instead of putting money into advertising, they're putting it into recycling, because they find that by enabling recyclability on a product, consumers may choose their brand over a different brand.
Companies would do best to have their design groups look at a circular, sustainable way of designing their products, because it comes down to design.
We focus on setting up solutions where solutions don't exist. It would be great if TerraCycle didn't need to exist. I mean, that would be an ultimate dream, that garbage doesn't exist as a problem, and that then we wouldn't need an organization like this to be out there. But until there isn't a problem, we're here to try to bring some level of solution.
The circular dream is not recycling. The transition to the circular economy needs to kind of have two parts to it. So one part would be thinking quite clearly about redesign. How do we design this in a way that there isn't waste falling out at the bottom, which needs to be recycled in the first place? If we're really kind of pushing for serious change, I think we need to be thinking in that area, like how do we design out this stuff as much as possible? But we know that transitions don't happen overnight. There's a massive cleanup job to do.
For us as individuals, the short-term step is to vote with our money for the future we want with what we buy. People are waking up more than ever.
The circular economy is an idealised version of what the economy could be like, whereby instead of having this extraction, use, disposal model, materials are used continually, or they're suitable for biodegrading.
Africa is well placed from benefiting from a circular economy. In many countries like Uganda, waste is not segregated. It's one of those visible problems.
600 tons of plastic is disposed of every single day in Uganda, and there is no formal recycling processes. EcoBrixs is a closed-loop recycling system where we buy plastic from the community and turn it into local marketable products.
EcoBrixs eyambidde ddala abantu kubanga abantu bafunyeewo emirimu, banneiba baafuna emirimu. EcoBrixs efunye obuganzi mu bantu kubanga ebayambidde ddala. Era abantu bagyagala ate era bagimanyi.
By buying plastic directly from the community, What we find naturally happens is we put money directly into the most vulnerable people's hands, so they can earn an income and have a status here in the community. So that's the first point of impact, but that can expand and grow, and we've been able to really excitingly do that with a Plastic for Education program, where children or community members can bring plastic, and it goes directly towards school fees. Engaging young people straight into the habit of recycling and seeing there is value to be gained.
Tuwa omukisa buli muntu kubanga tulinamu n'abalema, tulinamu baddeefu, buli omu tukwasaganya naye ne tubeera kitole.
50% of our collection network is managed by the disabled community, and that is something we're really, really proud of. We're going to keep that stat as we expand out across Uganda.
Kati yeetoolodde emyaka 3 ntambuza mwaka gwa 4 baana ali nkola emirimu egy'enjawulo nga ntunga ngatto ne bajja ne bandiiramu ekigambo nange nenkikola ki nenkikwata nenkigula nenzija nentandika okukola nabo era bansasula bulungi sinaamu kwemulugunya kwonna era nange omulimu ngulimu ngukola n'abanyambako ab'enjawulo nga bwe mulabyeko awo nga sirinaamu kweganya.
To have a good job that fulfills you as a person, but also gives you the money that you need to be able to provide for yourself and your family, is the foundations really of building a good society.
We have 25 community collection hubs, centralised in markets or trading centres, and then we have sort of 3,000 income opportunities from people that bring plastic to us. So although they're not our direct employees, it is everyone earning across the whole chain.
Guno omulimu ngukoledde emyaka 6. Okulonda buno bukobe n'embutunda nga nnyuddwamu okuweereza abaana bange n'okwerabirira n'amaka gange.
Plastic is a very visual problem in Uganda. It's often burnt on roadsides and in landfills. When it's burnt, obviously produces really toxic gases. And because there isn't much awareness about those dangers, plastic is burnt within home settings or even within school settings and even worse within hospital settings currently in Masaka. So we are really trying to spread awareness around that.
Air pollution is responsible for over 7 million deaths annually, globally. And for the case of Uganda, air pollution is responsible for over 22,000 deaths per year. People literally burn most of this waste in the communities, and that increases on the air pollution, which is already a big challenge in Uganda. What EcoBrixs is doing reduces this waste that would have actually been burnt.
So what we make currently is plastic lumber, which is a material that can replace wood. And then we're moving into interlocking bricks and face masks made purely from recycled plastic. We've made playgrounds, benches, we've made advertising frames. We replicate what's already on the market, but make it out of plastic. It's a never-ending spiral of innovation.
EcoBrixs have got this socially conscious model of waste collection in a context where there isn't enough work to go around, where working poverty is high, in a context where the plastic waste is causing immediate direct health problems for people. And they're bringing together these problems and turning it into a model whereby you can give people good wages, give people good incomes, and tackle the plastic waste problem while also running what looks like a viable business.
I have a sense of hope, when I look at various small enterprises in the different communities trying to do the best they can to change or to transform that waste into a product that is useful in the community.
Closed-loop systems need to be adopted around the world, not just in Africa, but across the planet as a whole. Plastic waste stretches as far as the eye can see, really, in terms of its reach in a global capacity. So we know that this solution is an essential piece in the puzzle to the plastic crisis that is there.
The first important aspect to understand here is that the economy is part of the environment. If you look at economic textbooks, the economy and the environment as two separate boxes. You see arrows between those two interacting, but they are portrayed as if they are a different thing.
All the infrastructure that was created hundreds of years ago is for a linear economy. Transitioning from a linear economy into a circular economy will involve the work of governments and companies, also of consumers, and also of new technologies that will come about to bring impactful solutions that can accelerate this transition. Hi, I'm Jack Tato Biggio. I'm co-founder and CEO of UBQ Materials. Since the day of the Industrial Revolution, where we started producing quantities of materials in a very massive way, humanity was less exposed really to the damages that we were doing to the planet. Waste is being dumped. Recycling only accounts for about 10 to 12% worldwide. And even in countries where you have enormous amounts of recycling, like North European countries, you can reach 50–60%.
What we're making our material from is waste. Essentially the most abundant material that we could use. We're converting waste, and it goes all the way through this. So yeah.
UBQ Materials is a company that has developed a revolutionary technology that enables us to convert unsorted household garbage into a new plastic that is made out of trash instead of oil.
Cardboard boxes together with the plastic packaging of your yogurt, chicken bones, last night's leftovers, old newspapers, old magazines.
We can recycle everything. We can convert everything. Pure waste that we can compress and to do construction out of waste. So instead of the wood, we have UBQ. This is go for furnitures. We bring the UBQ, mixture with the plastic matrix, and become climate positive. Well, my dream that we will able to produce every plastic product that exists with the UBQ inside. It's a frisbee and it flies.
Of course, businesses have plenty of practical experience that move people towards the adoption of different products. In order for you to create sustainable products, you need to understand what is the true impact of your products throughout the supply chain.
UBQ is not plastic. It's the same price, it feels the same, weighs the same, acts and functions the same.
The conversion process is very unique. Since waste is very wet, it's very humid, we don't use any water. Our process is clean, our process is efficient, we don't have any waste, we don't have any sludges. All of this together converted into one usable, valuable material.
We're able to take all of the household waste. So that's everything together. Things like dirty diapers. Okay, that's something that is considered across the globe unrecyclable. What's a dirty diaper? It's both organic and it's a lot of different mixed plastics, which in regular scenarios, you're not able to recycle. Recycling needs each individual plastic and each material in its own individual stream. What we're able to do is we're taking in both the organics and the mixed plastics.
We're saving landfill waste, saving the methane emissions of organic material in landfills, which is huge, and creating a new material that is replacing oil-based plastic. I definitely see a future where 100% of our waste will be repurposed. The amount of waste that the world is producing is enormous. Frankly, one company cannot deal with all the problems. We need to act faster.
When it comes to how we as a global economy are transitioning to a greener and more circular future, I think we're on the right trajectory. We're able to provide that resource at a very competitive price. Because we're not dependent on oil, we're actually able to provide long-term price stability.
The economic theory has to take into consideration the impact of the economy and the environment. They are one single unit.
From governments, to institutions, to multilaterals, to capital markets, to companies, to consumers, we need immediate change, and it has to happen all over the value chain.
By transforming that linear process into a circular process, in which we take into consideration the feedback across the supply chain, we have a much better understanding of the impact of our actions in the environment and vice versa.
Less than 50% of India's population of almost 1.3 billion people has access to safely managed drinking water. Absolute Water's green sewage treatment plants convert waste into drinking water where it's needed the most.
Everybody deserves clean water. 163 million Indians do not have access to clean water near their homes. We have a technology that can clean water from sewage of all things. And that is everywhere. That is not only India-centric, it is Southeast Asia, it is Africa, it is all over the place. My name is Smita Singhal and I am the founding director of Absolute Water Private Limited. We convert sewage water into drinking water. The current situation in India is such that the pipe distribution in the entire country is very varied, and we don't even know half the time whether that is clean water or not, because it will be picked up from a natural source of some sort. There is no such thing as disparity of water. Water is there, but it is just not evenly distributed in the proper format as it should be, where every household should have access to water. This is what we call our biofilter bed. The biofilter bed has 6 stacks of food grade crates in which we fill all our organic and inorganic media, which includes the worms, it includes the wood chips, it includes the sand and the pebbles. Through this whole sprinkler system, this water is the fine sewage water that comes with all the bacteria, pathogens and everything that needs to be treated so that all the water can be evenly distributed. These are my heroes who do all the job for me. These are specially bred worms that eat up all the micropollutants from the sewage water that come through these little sprinkler systems, and they're the ones who do the real job. I have experienced several issues with water supply in my own home, where especially during the monsoon season, the sewage line as well as the water supply line has connected together, for which we get really dirty water through our pipes and taps. We have had to suffer skin issues, we have had to suffer with gastric issues, only because we could not get clean water supply and there was no way of checking it. We wanted something to come up which is something sustainable so that we never ever have to fall short of water, be it a pandemic or be it a water crisis. The whole idea is to never see day zero. We currently, through these installed plants, are treating about 3.5 million liters of sewage every day, which is giving you clean, safe water for over 600,000 people in the country right now. Sewage is something that is never going to stop. It's a pollutant that is available all the time, an available resource. The water that you can see here is the treated water that is coming up from the biofilter bed via gravity. This water is the first level of filtration that we do, where this can be used for horticulture, for agriculture, for groundwater rejuvenation, as well as for water body rejuvenation. One of the biggest challenges that we've always faced is the mindset of people. They have actually come up and told us that how can you expect us to drink sewage water? It gets very difficult to get through a mindset like that. We have now changed our strategy completely, where we have also said, okay, fine, if you don't want to drink water, at least use it for 70% of the usage of what you use water for anyway. Be it for gardening, be it for washing your cars, or be it for irrigation, be it for agriculture. This is what we call the ozone contact tank. This is where the regular ozonation happens through a natural method, and this is when the treated water from this goes for horticulture, for agriculture on this campus, but it can also be used for toilet flushing, for washing, for all other purposes, which is of non-human contact.
I think that Absolute Water has a very, very strong future because wherever water is polluted, I know I can treat it. I know the technology that we have come across can be used anywhere in the world. I'm hoping I get the support of the local governments to make sewage treatment a mandatory exercise by every household, be it in a building, be it in an individual farmhouse, be it whatever. Because if I'm able to treat the sewage at source, it does not go into the pipeline, that effluent does not get into the rivers, and in every which way it is environmentally viable and economically viable because you make it into a self-sustaining system. If our company can help even a fraction of the world with clean drinking water, we would create a legacy that can never be compared to anything else. I want to make every drop count.
In nature, everything is connected. That means we're all in circles. So that means as soon as we emit something that is not really belonging there, you will have an effect on the environment.
There are 5 trillion pieces of plastic contaminate the global ocean surface, and what we do know, the vast majority of those particles are microplastics.
Microplastics are carried into the drain system, and the drain system is carried to the water treatment plants or directly into a local river. So therefore, the microplastics can go either into the water environment, the marine environment, or directly, if small enough, into the ambient environment.
For me personally, and also for the other co-founders, we have a huge passion for water, especially sports and activities around water. I'm a sailor myself, we have surfers and divers, and that was also where we encountered plastic pollution years ago, which stimulated us to start brainstorming and thinking about solutions to stop that plastic pollution in rivers before it actually flow into the ocean. My name is Annemarieke Eveleens. I'm one of the co-founders of the Great Bubble Barrier. Recycling currently only happens for 14% of plastic, so it doesn't have that much of a significant impact on plastic pollution currently.
One thing that is apparent now is that plastic pollution is a local problem, but it doesn't stay local. My name is Philip Erhorn, I'm Chief Technology Officer and one of the co-founders of the Great Bubble Barrier. We as the Great Bubble Barrier think that bubble barrier systems can be a very effective solution to stop the outflow of plastics from rivers into the ocean. The way the bubble barrier works is, if you think about the river, it will flow naturally, and we're making use of that natural flow. Unlike other solutions where you have to place physical barriers, we're trying to be a non-invasive solution. So what we do is we just place a tube diagonally on the bottom of the river, and that tube has a lot of tiny holes, and then we pump air through it. These air bubbles will rise to the surface. The rising will actually create an upwards water current, which can push the plastic which is suspended underwater to the surface, and then at the surface, together with the natural flow of the river, it's all pushed to one side, and that's where we place our catchment system. With the bubble barrier in Amsterdam, we were really keen to see how much plastic we're really collecting over a whole year throughout the whole seasons. Because we do know there's a large variation in the amount, but also the types of plastics that you can catch in a river. We set up a monitoring program to evaluate the catch.
In Amsterdam, the bubble barrier it has been designed to be emptied once per week. Currently, we have to empty it 3 times per week because we're catching that much pollution. So I would say the impact is bigger than we expected.
Plastic leads to microplastics, and these either are so small that they can actually be caught by any wind that's present and taken up into the air.
Microplastics in the oceans, most of them you don't see, but that doesn't mean that they don't have an effect.
They not only contaminate the oceans, they contaminate food that we eat, drinking water, dust.
Microplastics are definitely a more complex and more difficult problem to solve, mainly because of their size. They become really, really small, down to the point that there's even no technology currently exists that could effectively remove microplastics from the water, especially in open water and in natural water bodies. If we don't stop it in our rivers, it will become a regional problem and even an international problem where we have plastics traveling from the oceans into our seas and then basically to anywhere in the world. We have definitely not hit our, let's say, size limitation. We catch currently around 86%, which we think is very high for the fact that we can get the trade-off of not having to place a physical barrier, which in a lot of cases would not be possible, and we can still effectively catch plastic.
Worldwide, we are facing the challenge that at the moment there is no policy that dictates on which organization has the responsibility to clean the waters from plastic pollution. We are working to overcome this and to make sure that it will become easier and easier for policymakers to implement solutions like our bubble barrier. So we help them getting the right permits, to have the right tools to actually make sure that this can be implemented as soon and as fast as possible.
A lot of people and governments always saying we need innovation and we need sustainability, but very often we don't have enough resources coming towards those innovative projects to actually do what they can do.
Policymakers are at the top of the food chain, as it were. They have the ability to bring in major change. I think we are beginning to turn the corner, and there seems to be enthusiasm for a green recovery.
I think you can accelerate sustainable innovation, first I'd say through awareness, because people need to know the problem to know what to innovate.
The ultimate goal with our bubble barrier systems would be that we deploy them in almost any waterway and river where we have plastic entering the waterways. But also that we see what are these systems catching and can we learn from that so that we implement new measures on land so that in the future maybe we have no plastic ending up in the waterways in the first place and we can start removing our bubble barrier systems because they're not needed anymore.
Looking at the future of materials, I think nature is going to make a huge comeback.
Seaweed is such an exciting material to work with because it has some of the properties that plastic has, such as the fact that it's flexible, it's really light, it's transparent. Seaweed has a great potential to completely change the packaging industry, especially the one of single use.
We're doing this because we really want to see some of that plastic replaced by seaweed and plants as quickly as possible at an industrial scale so that we have the impact we want to have. I'm Pierre Paslier. I'm one of the co-founders of Notpla. I started my career as a packaging engineer. I was working for the cosmetics company and I was working on projects that were all wrapped in plastic. Cream jars, shampoo bottles, industrializing them in the hundreds of millions, and seeing all these plastic bottles running on the lines kind of get me a little bit anxious about what plan we have for them at end of life. And that's where I started the project with Rodrigo to really try to find alternatives to single-use plastic that would be a little bit more natural, a bit more like fruits and vegetables. And after a bit of prototyping, we made the first edible bubbles that we've called OHO. So Notpla stands for not plastic. This is really at the core of what we do. We create packaging solutions that are not made from plastic.
My name's Louise. I'm the research director at Notpla. So this is the Notpla solution. It's 100% natural and a seaweed-based material that we use to make our OHO product. And this is basically a replica of what happens on the machine. We get a little film, a little spray, wait a few seconds, and then we'd get a little seaweed membrane, which looks a little like this.
The past century has been the century of man-made materials. We've been very excited about creating things that had never really existed in the environment. Plastic has only been around for a few tens of years in the packaging world. Before we were relying on glass, on other materials. We had a lot of reusable containers. Plastic has enabled us to have much longer supply chains and become a lot lazier when we design products. When you walk in a supermarket, you almost forget that your eyes are literally looking at plastic everywhere. Actually, it's a very important material. It plays a crucial role in keeping the products fresh and protected along the way. But that's thrown us in a direction that is not really sustainable. The world consumes 141 million tons of plastic packaging every year. It's completely alien to this planet, and nature doesn't know how to deal with it at end of life. If we don't change course, we will just keep on digging that hole deeper and deeper. Seaweed is a really interesting resource. It's highly renewable. Some of the seaweed that we've been testing in our lab grows up to 1 meter per day, so it's the fastest growing organism on the planet.
There's so many different species of seaweed. There's over 12,000, and from a chemistry perspective, that's a massive amount to play with. Depending on where it's grown, it can have different properties. So you can have seaweeds growing on the north coast of Scotland that have been through really, really harsh conditions. You might have more cellulosic components, so more fibrous material, which means it's a lot stronger, it's a lot more robust. And then you can also have seaweeds that are in like the Caribbean, so used to really hot climates. So that again gives you a whole wealth of different chemistries to play with.
I'm Eleonora Rombola, and I'm a designer at Notpla. Here in my hand I have an ojo, which is an edible bubble of water. Notpla films are great for encapsulating dry contents as well as oily ones. We really use all of the parts of the seaweed for a really truly circular process.
When you have something that is truly biodegradable, nature takes that material and makes the nutrients for the next plant or the next seaweed. We really look at nature and natural solutions and integrate them in our packaging solutions. And luckily that aligns very well with the new single-use plastic directive from the European Union that has for the first time taken a very strong stance on what is and isn't a plastic. There's two criteria. The first thing is that a material should be widely, abundantly available in nature to be not considered a plastic. And the second one is that if it comes from nature, it should not be chemically modified. Bioplastics are essentially plastics that are made from a resource that initially wasn't petrochemical derived, it was coming from plants. But those plants, they were chemically modified to the point of making a plastic out of this. Notpla, it's also a play on word because it can read not PLA. PLA is one of the main bioplastic that is, to our opinion, really greenwashing this space and not delivering in terms of sustainability what people expect from it. So when we want to create at Notpla biodegradable packaging, we really want it to disappear within weeks rather than within years.
We test our materials in our warmery. What is great about them is that they really behave in a similar way to what an orange peel, for example, would, disappearing completely in a few days and leaving no traces behind, and neither of microplastics.
Seaweed hits all the boxes for us when it comes to sustainability credentials, but we don't think that everything is going to be solved by seaweeds. So we are incorporating a lot of other materials in our formulations that meet the same criteria of being natural, abundant, biodegradable. Recently, we've started to do a lot of work around rescued material, things that are byproducts from other industries, especially from production of food. Together, we have a huge shot at reversing all the harm that packaging has done on the planet and turn it into something that is really positive.
It's really exciting as well that more and more small businesses or companies are looking at this type of materials for their solutions.
We know that we have to act right now if we want to stay alive and well in this planet. The future is bright for seaweed.
Mushrooms are magic, but I think where the magic really comes in is mycelium. Mycelium is the underground network of thin-like threads of hyphae that communicate to each other and can be used to solve so many problems the world faces. It can grow exponentially to replace something that's been in the ground for 50 million years before it's extracted. Nature has evolved over billions of years, so it has natural systems and processes which we should be learning from. We should be investing in alternative materials that come from nature.
The future for mycelium-based materials is really exciting. There's several reasons why mycelium is making huge headlines. Not only can it be grown in a very low impact and sustainable way, but it's really a very versatile new biotechnology. The mycelium product can be biodegradable because all the components are natural. It's naturally fire retardant. It's got great insulation properties, but also has an amazing ability to clean up waste.
We use mycelium as nature's glue to bind together loose particles of agricultural waste to become the solid form. I'm Paul Gilligan, CEO and co-founder of the Magical Mushroom Company. Magical Mushroom Company is a challenger company with a very clear mission to make polystyrene packaging a thing of the past. Huge amounts of polystyrene are used around the world, which protects very heavy products in transit. What we do is produce an equivalent packaging solution from a mycelium agricultural waste, which will biodegrade within 50 days, but will do the same job. Mycelium is an untapped material in potential. Certainly in our industry, it's almost an infinite market because there's so much polystyrene being used with virtually no recycling facilities. So it's all going to landfill or incineration.
Compared to more traditional packaging, ours is totally natural, that is both biodegradable and compostable. My name's Stuart Townsend and I'm Head of Operations at Magical Mushroom Company. In the cold store here, we've got the substrate that we use to grow our products from. It's a combination of hemp and mycelium, and this is dormant at the moment. As soon as we take it out of refrigeration, that's when it starts coming to life. We take the raw material, it's then blended down into a consistency like this. This is then placed into our trays, and we just smooth them down and just fill all the voids. For each product, we have a different mold, and that shape is what the mycelium and the waste grow into. We place them in the grow pod, and it'll stay in here, wrapped up at ambient temperature with a low humidity. So this is the final part of the process where we take it from a living product to an inert product. So we place it in the kiln, that removes the moisture content, and it also kills off the mycelium. And then we end up with a product like this. We can make literally anything. So any type of packaging that you see, historically made in polystyrene, that could be a surround for a bottle, or something as simple as the packaging that would go around a washing machine. So the list is endless.
Our vision for the future of packaging, certainly in secondary packaging, is that we will replace up to 50% of the polystyrene market within the next 10 years. The scale of the agricultural waste we're using here in Atom is 10 tonnes a week, and that's equivalent to taking 5 tonnes out of the polystyrene market every single week. Our other factories do 3 times that volume. So we see a day in the near future where we have at least one factory in every country.
Anywhere where there's agriculture is a great place for us because the product's immediately on a doorstep for us to use in our factory to make products for the future. It will give us the full control over the journey of that product and significantly reduce our carbon footprint. It'll also reduce the cost of the product, which is key.
The aim is to create a future where there's no waste, to really think about closed-loop circular systems. The exciting thing about circular systems is that actually economically they're now making a lot of sense.
We are able to take back the spent packaging as a feedstock again. So it's full circularity and full recycling, where by this time next year we've actually got a carbon neutral manufacturing process.
We have the ability to grow the bespoke products that we need, but also transform it through quite simple manufacturing processes that don't require extensive heat or energy. As consumers, we're also implicated within these circular systems, how it's disposed of, and then how it becomes reused within that system.
So there needs to be lots of joined up thinking with policy and governments, how we label these materials because it is new, how we get it back, and how it's used at the end of life. Mycelium is a magical solution. We're all inspired every day by this amazing material. We just want more and more people to adopt it. We're just starting to uncover the opportunities for its use, and then I think we'll see that becoming a mainstream part of many industries in the future.
Sound rolling, camera rolling, and let's have a nice walk and talk.
Yes, when I started this journey, I used to say, when I see a landfill, I see a gold mine. ECONYL is a nylon polymer, perfectly identical of the one coming from petroleum, but using a very special technology, which is regenerating nylon waste. Can you imagine that from this fishing net, or this fishing net, you can make this parka? Amazing, isn't it? Every single component is made with recycled nylon. Buttons, you can see zippers, ropes. ECONYL is a beautiful nylon, but with a very different story. Nylon is used because of its performances. So you can make active sportwear, or jackets, or swimwear, but synthetic fibers, they are representing a problem because they derive from petroleum and are basically non-recyclable, all possibly single-time recyclable. At the end, they are finishing in landfill or into incineration. The textile industry is consuming more than 100 million tons per year of fibers. Nylon is one of the biggest ones. Clearly, we have to change these trajectories. ECONYL is returning to the original building blocks with a chemical system which doesn't take new resources from the planet, so we start entirely from waste. It is doing this with a very low carbon footprint, between 70 to 90% lower CO2 emissions. We approached the fashion industry proposing to make products in a different way. When we started this, they all laughed at us. It was a big challenge to develop the technology. Other people have tried, even large chemical giants, but they miserably failed. Aquafil is collecting or buying not only fishing nets, but also garments or carpets. We are collecting waste that normally the plastic industry doesn't like to recycle. When we are taking back an aquaculture net, fishing nets, there is a lot of water inside. In an aquaculture net, you have anti-fouling agents like copper-based materials. We need mechanically to remove these agents from the fishing net. Remove the sand, remove any organic debris. We like to explain the ECONYL process with a description of 4 steps. The first step is rescuing waste, collecting them, sorting. Once you finally have your waste here in Slovenia, here is when the process starts. There is a mechanical part, which is grinding and helping to separate a different kind of materials, and then you enter into the chemical step. Once you have a pure monomer, well, at this point, you start with remaking nylon and you don't need to change anything. And then the 4th step is our customers. They have to reimagine how they are making products to help us to recover them at the end of use. So we are continuously introducing solutions for our customers, like, for example, ECONYL in the form of pellets for molding buttons or for making zippers, or in the form of yarns for making sewing threads. ECONYL is infinitely recyclable, giving endless possibilities to designers and engineers, and with a very low carbon footprint. When Aquafil is separating byproducts, we try always not to landfill them. If it is copper-based, we send them for recycling, and we get copper that, instead of being mined, It's used for different applications like agriculture. When we are separating a carpet, normally you have the fillers that are going for road construction or for cement production, and other synthetics like polypropylene that is going for plastic recycling. We have now finally started also to make new yarns for making new fishing nets, so really approaching also circularly the fishing industry. Step by step, scaling up our process, we have continuously reduced our cost and we will become cost competitive. Identical to, let's say, the petrochemical nylon products, this will largely depend on how brands are going to make products in the future. Because if they make them with the end in mind, so more easily recyclable, this cost will dramatically decrease. We can remake a fishing net, or we can make a carpet, or we can make a plastic part. And this is doable infinitely. So you really don't need to take materials from the planet every time you are making a new product, but you just have to take them once.
When you look at the history of textiles or garments 100 years ago or 200 years ago, garments used to be highly valued. They were expensive. So garments were really a product that you cherished and kept for a long time. In the last 10 years, garments and fashion items have become sort of a consumable item.
The textile industry must change because it uses a lot of plastics in a way that is not sustainable. That means we use resources that are non-renewable, we are not using the plastics after they have been used, and as a consequence we have a negative impact on the environment and on the climate in general.
My name is Matthias Fuchs. I'm the Chief Marketing Officer of OceanSafe. OceanSafe is a company that is on a mission to revolutionize the textile industry. We help brands and retailers develop fully circular, biodegradable textiles. We have biodegradable synthetic fibers which are developed by us. We have a fully certified supply chain which we provide to our customers, our retailers and brands, and they manufacture their circular products there.
Mein Name ist Manuel Schweitzer, ich bin der Gründer und der CEO von OceanSafe. Ich bin seit über 40 Jahren im Bereich von Textilien unterwegs und man könnte zusammenfassen, Textilien sind mein Leben. Die Textilindustrie ist nur ein Part, der ändern muss. Alles, was in die Natur kommen kann, muss für sicher sein für den biologischen Kreislauf. 80% der verlorenen Erde, das dürften ca. 25 Milliarden Tonnen Erde sein jedes Jahr, die wir verlieren, muss ersetzt werden und somit muss alles, was in die Natur kommt, wieder Erde werden. Also ist das Ziel von OceanSafe, eine Baumwolle, was eine sensationelle Phase ist, im Labor nachzubauen. Und diese Phase hat dieselben Eigenschaften, aber sie kann skaliert werden und hat nicht den Verbrauch der ganzen Ressourcen, wie man für eine Baumwolle einsetzen muss.
We help our customers develop fully circular end products. These end products must be according to the OceanSafe standards, and these are that the end product is fully circular, it's biodegradable, it's manufactured completely without any toxins. We are not a producer ourselves, so we use partner factories where products are being manufactured. But right now, the product lines that we collaborate with are bed sheets, terry towels, bathrobes, and interior fabrics. Our model, our fibers, and our entire concept that we have is made for highly industrially scaled solutions. That is basically our challenge, is the transition from a great concept, from a great philosophy, from great values and standards to an implemented industrial standard. But that's our journey.
There are 5 trillion pieces of plastic contaminate the global ocean surface. And what we do know, at least not by mass, but in number terms, the vast majority of those particles are microplastics. The textiles industry does contribute to the microplastics problem, and that's because, at least for woven textiles, they wear and tear during use. So for example, walking on a carpet, or just us sitting and moving in these clothes, or when we wash clothes, all that mechanical stress does cause it to fragment. So textiles can emit plastic microfibers to the environment.
The plastics that are mostly being used today are non-degradable. That means they last a very long time in the oceans. It is important now to an eco-design that there is a producer responsibility for the product that they are producing. Making biodegradable fibers or compostable fibers, the process is more or less the same as synthetic fibers. You can get the chemicals and you can synthesize these bio-based products. These bio-based products can be made biodegradable, but you can also have the plastics that nature already made. And that means proteins, carbohydrates. These are the molecules, the polymers essentially, that are already available in nature and are also bio-based and biodegradable.
10% of the oil and gas industry goes into plastic, and a lot of that more systemic, deep-rooted issue in consumerism. If we can curb that, that's going to have lots of positive repercussions for lots of other issues that we face as a population.
Ob es schnell genug geht in der Textilindustrie, das wird sich zeigen. Auf jeden Fall ist jetzt Bewegung drin. Einer von beiden wird gewinnen. Ich setze ganz klar auf die Kreislaufwirtschaft. Ob sich im Moment gerade was ändert im Bewusstsein der Textilkonsumenten? Ja, glaube ich ganz fest. Wobei die Moral war noch nie eine Stärke des Menschen. Also es gibt nur eine Lösung. Unsere Textilien müssen günstiger sein, besser sein, schöner sein, und dann haben wir überzeugende Argumente, weil gut sind sie.
At the end of the day, we are idealistic people and we do want to change the world a little bit, yes. Our dream would be to change the world dramatically.
To be able to recycle textiles back to textiles, you need to be able to disassemble clothes or textile products, because a garment is not textile. There is a button, there are labels, there are zippers. This needs to be taken out before you can get back to the textile that you then can recycle at a high quality. This disassembly is what is the main bottleneck today in the textile recycling industry.
If a garment costs less than a pizza, there's a problem. In my dream, I would see no landfills, meaning that all garments are recyclable and circularity is the norm.
Resortex originated in 2017. I realized that I could use my engineering background to solve this problem to make fashion circular. The solution itself, technically speaking, is a combination of thermal soluble stitching thread, so a thread that will melt at high temperature, that can be used on existing sewing machines. And then we have those smart disassembly systems, which are thermal machines in which we can heat up products that were previously stitched with Smart Stitch and make that Smart Stitch thread disappear, allowing the product to fall apart.
It's exactly like a kind of Lego game where the pieces need to put together, and then when you put them apart, they just fall apart, and it's easy to put them together again in a different form.
In the end, what we offer is an easy way to recover the different materials.
Solving the root cause of the problem by designing the fashion to be disassembled and then providing the disassembly oven to make the solution holistic, functional, and profitable.
And making sure that recycling is the new standard.
The combination of a smart stitch and a smart disassembly, what we can ensure is that all the textile products are separated, and this ensures that you can recuperate up to 90% of the material. to show you a concrete example, here we have the Dennis trouser from Berska collection that we released with them last summer. In this case, if you want to recycle this product, you would commonly shop the upper part, so you will waste all this material. In our case, what we do is that we selectively disassemble the zippers, the button, and the waistband, and 90% of the cotton that is in this material can be recycled. And this burst is quite interesting because manual, normally you can recuperate just up to 50%, and in mechanically we are also around this value. So we can almost double the amount of material that we can use as feedstock after our process.
$92 million tons of textile are wasted every single year. 1% only is recycled in a circular manner, meaning textile to textile recycling. Up to 10% can be sold as a second hand, while the rest, unfortunately, is shipped from the global north to the global south. Once they arrive, they are mostly incinerated and landfilled on the spot. The countries don't have the infrastructure, it's polluting soil, water, and air. The current financial model for not only fashion industry but other industries is a linear model. All the value of the material is lost at the end of life. We keep the value of the material in the value chain of it and bring the raw material back and avoid sourcing a new raw material. And with this we are able to perform this circular economy that will respect the boundaries of the planet and furthermore is profitable. If every garment has a smart stitch, it means this garment is designed for recycling. At a global level, in the coming 10 years, if we implement resorting solution on all the fashion industry, we can reduce up to 200 million tons of CO2 annually.
Recycling technologies need to work at scale, sorting technologies need to work at scale, disassembly solutions need to work at scale, and then we need to interconnect them.
We want to be disruptive, we want to create a systematic change in harmony with what is existing. We don't want to be destructive. This year, we were bombarded by heat waves that engulfed the globe. A lot of records were broken in terms of temperature, natural disasters. The planet is urging us to make a change, and the change must be now.
I believe in, again, being proactive and be part of the solution instead of being part of the problem. I meet enough people that really want to be part of the solution, and that gives me hope as well, and that also gives me the energy to continue.
The biggest contributor to global warming in Kenya right now is the public transport sector.
At least 4 million passenger trips are made every day, but most of them using diesel.
There's a lot of congestion on the roads, which means there's a lot of pollution. Electric vehicles make sense. 90% of the Kenyan grid is renewable at the moment. We have enough surplus of electricity to power our grid and to be able to charge and support electric vehicles in Kenya.
Nairobi and Kenya and Africa is geared up to electric mobility. That's our mission, to make sure that we electrify Africa's transport system. ROM is headquartered in Nairobi, Kenya, next to the national park. It gives us an inspiration of building a cleaner, safer environment for both wild animals and also human beings. We produce electric buses and electric motorcycles.
Motorcycles are used by basically everyone here in Kenya.
So the cheapest way to move from one point to another in Nairobi is using the boda bodas. So these are the commuter motorcycles.
It's how we get food to our local market, to the nearest bus station or much deeper rural areas. So many people use it to be able to have a source of income that's reliable and stable. But there are approximately around 2 to 3 million motorcycles on the road, and the number keeps growing.
Every year we see about 600,000 motorcycles being registered annually. And these motorcycles are fossil powered, which means they have carbon emissions. That only means that we are getting to a very sensitive point in Nairobi where pollution is at a new high. Every year, the carbon footprint grows. Electric vehicles are better in many ways. They have zero emissions, cheaper to maintain. When it comes to the cost of fueling an electric vehicle, already we are over 50% cheaper.
With electric motorcycles, we can be completely reliant on the electricity produced internally here locally, because already our grid is renewable.
So targeting the boda sector means that we are able to drive change from the grassroots. We give you a charger and a battery that you can move around with and plug into any normal power outlet. Makes it easier for our users to be able to recharge anywhere, to be able to replenish and to not lose any mileage. We also have a rental battery model where if you don't have time to wait for the charging, you can just swap and get a different battery that you can run with and then come back and pick your battery at the end of your business.
So the design of the Romeo all started with the belief and concept that we can build a product that will last for a long period of time. There are very few products that were designed for Kenyans in mind. Our unique topography in sub-Saharan Africa means that we have a very different set of climatic conditions. We have different terrains, from sand to rocky terrain. We've designed our product from scratch. Every single component on that bike has been designed right here in-house by engineers here in Rome.
So we make two types of buses, specifically designed and developed for the African continent. Our vehicles are designed here and also made here. And why this is important is so anybody who wants a spare part doesn't have to ship it from abroad, but can access that spare part there and there.
They are cheaper, more robust, and people who experience our products immediately fall in love with them.
We are providing solutions to Nairobi, to Kenya, to Africa for passengers to be on safe, reliable, very sustainable means, and to make sure that it's very convenient. The entire transport system has to be harmonized, work in one. Charging infrastructure is very critical in making sure that public transport is organized. It will revolutionize Africa's public transport system. We started off with Nairobi, and we're also looking into other cities in Mombasa, Kisumu, East Africa, Uganda, Kigali, Tanzania. So with these products, we're able to support an entire public transport system.
Kenya is ahead when it comes to working towards becoming a green economy. Rome has already done the work. We have done our proof of concept to make the electric vehicle adoption a reality. But right now, we need stakeholders to come into play. And that means the government has to come up with policies, tax incentives. We need to have local manufacturing. We need to build local capacity.
We need to be in the forefront. Right here, we can develop with climate solutions in mind.
Can we achieve our transport targets? Yes, sure we can. It is very important to create smart business models that can help to connect different players that will really help to achieve our transport goals.
For accelerating a sustainable transportation future.
The Rasa is an electric car. It has electric motors in all four wheels, but it doesn't have any batteries. This car differs from most of the zero-emission cars that are available today. Although it is an electric car, it runs on hydrogen. It produces water as an exhaust product. There are no carbon emissions. My name is Hugo Spowers and I'm the founder and MD of River Simple Movement.
This is the fuel cell. This is the heart of the vehicle. Hydrogen is pumped into the fuel cell and is turned into electricity.
It's exactly the process of electrolysis, but in reverse. So in the school experiment, you put in electricity into water and out comes hydrogen and oxygen. In a fuel cell, you put in the hydrogen and oxygen and out comes electricity and water.
This electricity then runs through these high voltage cables where it generates power in the wheels. My name's Johnny Price. I am a vehicle technician here at River Simple. The vehicle is all made of carbon fibre. It's very, very strong material. It's very low maintenance. It doesn't rust. It's very lightweight. It's lighter than steel, but it's equally as strong. It's making the jig up that mounts onto.
We don't argue about whether solar PV or wind turbines are going to win the renewable energy race. They're just different and we need them both. And the same is absolutely true of batteries and hydrogen. We can decarbonise much quicker if we pursue both battery and hydrogen cars alongside. Battery cars are great for short-range, regular duty cycles. But for longer range or high utilisation, battery cars become increasingly inconvenient. You have to plan your day or your week around your charging schedule. This is where hydrogen cars become much more practical.
It's really easy to refuel. You just park up, you attach the nozzle, press the button, and then you wait for 3 to 5 minutes. I'm Sarah Gore and I'm the trial analyst at River Simple. When it stops, it tells you, put the hatch back on and drive away. Really simple.
Put a filling station in a small city or a large town. Anybody has a reason to come into that city once a week. That's why it has a 300-mile range, to be at least a week's use of fuel.
The way we're consuming raw materials at the moment is really unsustainable.
We're probably the only car company in the world that hopes never to sell a car. We will only ever sell a subscription service, so customers will typically sign up for a 3-year contract, much like leasing a car today.
We're moving completely away from the take, make, dispose way of doing things. Our customers will pay one monthly subscription that includes insurance, servicing, maintenance, fuel, breakdown recovery, everything. We're motivated then to make a car that lasts as long as possible, ultimately meaning we reduce our waste and we reduce the amount of raw materials that we need.
From selling cars to selling mobility as a service is a critical part of building a sustainable transport system. The whole company is designed to bring cars to market that have the lowest possible environmental impact.
By thinking on supply chain as linear processes, we have created a very unsustainable path that has very big implications across the globe. By transforming that linear process into a circular process, we have a much better understanding of the impact of our actions in the environment and vice versa.
The manufacturing model is based around the fact that we're making these cars out of carbon fibre rather than steel, and the optimal scale for a plant is about 5,000 cars a year rather than 300,000. These plants will each employ about 200 to 220 people. This means that we can bring jobs into communities that are far too small to support large-scale modern manufacturing.
By having a local supply chain, suppliers are probably going to be more reactive and responsive, and so you can respond to challenges much more quickly and efficiently.
Oh, there we go.
Obviously it's better for the environment because if you're closer together, there's going to be less transport, less energy used. It's better for the local community.
We're working with other vehicle providers, finance providers, infrastructure partners to build an alliance to demonstrate this strategy for bringing hydrogen to market at a local scale. Our interests are aligned completely with those of our customers, and our interests are aligned with policymakers and the environment. The more efficient we are, the more we conserve resources, the more value we recover at end of life of cars, the cheaper it is for customers. This makes sustainability profitable. This circular model can be a win-win for businesses in all sorts of sectors because it's more profitable, delivering lower environmental impact and lower total cost of ownership to customers than selling product.
If the governments are saying we need to invest in electric vehicles or hydrogen, that is a really, really critical signal for startups, existing businesses, people who manufacture those things. The more we can scale up and ramp up capacity and production, the cheaper it becomes, and then we can quickly flip the economics. Could we imagine a future where we can go for a run with no smog every single day? Can we imagine a future where there's no red air quality alerts that are causing flare-ups with children who have asthma or adults that are vulnerable to poor air quality? Right now, the best options are to marry renewable energy generation with the fuels that we're using for zero-emission vehicles. And in the case of hydrogen, that could be similarly energy that is generated by renewables to produce green hydrogen. That is a great way to approach the challenge. My name is Erica Myers, and I'm the Global Director for E-Mobility at the World Resources Institute. Transportation is at the heart of everything, so to find viable solutions very quickly is paramount.
Arcola Energy is a hydrogen and fuel cell specialist focused on heavy-duty vehicles, so bringing together hydrogen and fuel cell technologies to decarbonize and take the emissions out of heavy transport. I'm Ben Todd, the CEO and founder of Arcola Energy. So we're here in Bowness with the Scottish Hydrogen Train project. What's happening here at the moment is a 4 million mile, 40-year-old train is being stripped of its historic drive, ready for a new hydrogen fuel cell power system based on the A-Drive platform to be installed. The train will then run around the railway here, fueled with green hydrogen from a refueling station that's been created just across the way. Our focus is on heavy-duty and in particular public municipal fleets. The reason for this is that in the early stage of the transition to zero-emission mobility, we're looking for places where we can deploy vehicles that have a very heavy duty cycle. Climate change and government policy means that we have to transition our entire transport infrastructure. But in the early stages of the market, we need to focus on vehicle classes where we can create a self-contained, financially sustainable and quick to deploy solution.
Hydrogen is a fantastic fuel for certain on-road or off-road applications. We think it's going to be a great option for heavy-duty transportation. So for example, the semi-tractor trailers, boats, ferries, trains, all these big, heavy modes of transportation that are going to be very difficult for electric to fuel. So hydrogen could be a great option for those modes.
We're in the process of converting a refuse collection vehicle from diesel to hydrogen fuel cell. It's halfway through having the diesel engine removed, hydrogen tanks, fuel cell, battery and electric motors installed for demonstration at the COP26 Climate Change Conference and then to go into service with Glasgow City Council next year. My name is Simon Milius, I'm the Engineering Director at Arcola Energy. Heavy-duty vehicles are a great target for hydrogen fuel cell technology because they need a very, very high amount of stored energy. If you put on a battery system big enough to power a refuse collection vehicle through its whole shift, or a bus that's working really hard doing 18-hour shifts, you need such heavy batteries that the vehicle payload is compromised.
So they're on the road a lot. Ideally, it's a back-to-base operation, so one filling station can support a large number of vehicles.
Underneath the cab, we have the fuel cell module, which is hybridized with 2 traction batteries between the chassis rails. So the power from the fuel cell and the battery is driving the traction motor, which turns the prop shaft to drive the rear wheels.
The scale and speed of the transition for sustainable transportation is far too slow. We need it to accelerate by anywhere from 16 to 32x in order to meet our 1.5 degree Celsius targets for global warming. Policy is critical for accelerating a sustainable transportation future. If the governments are saying we need to invest in hydrogen, that is a really, really critical signal for startups, existing businesses, people who manufacture those things that the government is encouraging. And the more we can scale up and ramp up that capacity and the production of those devices, the cheaper it becomes, and then we can quickly flip the economics.
Local authorities play a really critical role in the transition to zero-emission vehicles. They'll have a strong influence on the emission control policies within cities.
When it comes to private corporation decisions, I believe in change agents, individuals within the company that are encouraging their leadership to make a certain decision that benefits not just their company, but the planet.
We've spent over 100 years now optimizing our use of diesel and petrol, so the cost is very low, it's powerful, it's effective, and now we need to replace it. So any new technology we bring in to replace diesel has a really high bar for performance that's been set. So we want all of the benefits of this brilliantly optimized but dirty technology delivered at the same price, at the same convenience, but zero emission. We've got a real challenge to meet, but we also have a really amazing opportunity.
I do have hope that we can make the argument to the decision makers and the leaders of our planet that this is the most important issue that they can work on today. They want to have a legacy. Sustainable transportation is one of those things that they can do to have a legacy.